that. Good afternoon. Welcome to our CPD on whole life carbon assessments, or WLCAs. My name's Anna. I am one of the co-founders of SRE and the managing director.
Hi, I'm Manas. I'm a sustainability consultant specializing in whole life carbon assessment and other sustainability services.
And hi, I'm Adam. For those that know me, I'm senior consultant specializing in environmental compliance and whole life carbon, heading up the sustainability business unit.
We're running this CPD because whole life carbon is becoming increasingly recognised in the built environment, but it is quite it's a relatively new term. We're hoping that by the end of this CPD, some of the terms will be demystified. We'll have an understanding of how the assessments work, and also the value that they can have to any existing building or new development. We're going to start sharing our screen. Manas is going to kick off the CPD by talking about whole life carbon, but specifically the differences between operational and embodied carbon. We're then going to outline some of the principles of WLCAs, and then Adam is going to talk about a case study that we have advised on, where the resulting changes to the design actually improve both the embodied and operational carbon, and some other exciting surprises. I think we're probably all very aware that it's policies, guidance and regulations that are driving these changes. We're going to talk about those that are in existence now, but also some that are coming down the line. And at the end, we'll give you some key takeaways that we feel are the really important nuggets to bear in mind. Manas.
Thanks, Anna. So, as we are going to delve into the concept of whole life carbon, did you know that the built environment is contributing 25% of the nation's carbon footprint? And if you are aiming for a net zero future, the concept of whole life carbon has a crucial role in playing for us having a sustainable future in the buildings. As you can see over here, whole life carbon emissions are some of all greenhouse gas emissions and removals of both operational and embodied over the life cycle of the asset. Greenhouse gas emissions are the gases such as carbon dioxide, your sulfur gases, your nitrous oxides, which tend to increase the temperature of the atmosphere, whilst removals on the other side is sequestration or literal removal of the greenhouse gases from the atmosphere in the buildings, which is primarily done by timber elements. Whole life carbon encompasses all the stages of a building's life cycle from cradle to grave, and provides a holistic picture of the building's environmental impact. Focusing on the two big elements that make up the whole life carbon are operational. Operational carbon relates to the carbon emissions associated with the energy used to run the building. And these are projected to be reduced over in the next few years due to the constant effort of decarbonizing the grid by renewable sources of energy. And this in turn drives the grid carbon down. Embodied carbon, on the other side, is the emissions associated by manufacturing, your transportation of those raw materials and equipment gone into the building, and also the energy used on site to construct that particular asset. Both these factors make up the whole life carbon over the life cycle of the building. But to further break down that whole life carbon into three elemental categories, which are upfront carbon, your in-use carbon, and the end-of-life carbon. Upfront carbon, as the name suggests, is the carbon emissions coming with the manufacturing, your transportation of your raw materials, and also the energy used on site. And upfront carbon is usually accounted at the practical completion of any project of a building. In-use carbon, as you know, any building requires energy to run its operations, and there are carbon emissions associated with it. This is factored in the operational carbon of the building. And any given asset has repair, has maintenance, and also replacement of certain building elements, which comes with carbon emissions with it. Both these factors are into the in-use carbon of that particular asset. End-of-life carbon. With the building coming towards the end of its life cycle period, there are demolition activities associated with it. This particular category accounts for the emissions coming with the demolition activities and also the processing and disposal of the waste generated from demolition. But why is embodied carbon even becoming relevant in the next few years? Hannah?
Manus has put together this diagram to show two things. The first thing is we do believe that over time, both embodied and operational carbon of developments will reduce. Two reasons. Firstly, as we are focusing on embodied carbon during the design of buildings, it is going to get less also as more and more low carbon materials become available. However, operational carbon is also going to reduce over time as systems become more efficient, but also as Manus has touched on, the greening of the grid. The second thing you'll see is that the relative weighting between embodied carbon and operational carbon is changing over time. And that again is due to the decarbonisation of the grid. When we carry out whole life cycle carbon assessments, we obviously follow RICS guidelines. These are also the LETI principles which complement it. If we are going to reduce the carbon footprint of the built environment, it goes without saying that we need to build less. We need to retrofit wherever possible. And we need to also build light, which goes slightly hand in hand. Lightweight structures use less material. So less material needs to be sourced and less material needs to be transported to site. Build wise, we need to be thinking about longevity, both in terms of materials and systems. We need to be building for the long term. Using low carbon building materials is obviously goes without saying, and it's the renewable materials, but also just the natural materials. But it also needs to be noted that it's the whole life cycle carbon that needs to be taken into account. So bricks, for example, they might use a lot of energy in their manufacture, but they have a high level of durability and a long life expectancy. Build for the future. This is something, again, that's relatively new. So thinking about future possible purposes for a building, but also its end of life. The key here is circularity, and this is something that we touch on when we do life cycle cost analysis. Working collaboratively has to be the name of the game. It's not just down to the sustainability consultants to design out whole life carbon. It involves the whole design team and the client. But I suppose the multi-million-dollar question is, when do we start thinking about whole life carbon? Adam.
Cheers, Anna. Thank you. So yeah, Anna, as Anna's noted to you there, kind of applying those LETI principles, there's plenty of opportunities actually to influence the development of whole life carbon. And I think this graph on screen is kind of a great representation of that. Yeah, I think early stage involvement essentially equates to a maximised potential to have a positive impact. So involving a whole life cycle consultant around strategic design phase, concept design phase, yeah, there's a greater influence to impact that. Just to kind of note some of these, there would be procurement of sustainability operating businesses, procurement of the higher weighting materials, so your substructure, superstructure materials, optimizing core services strategies, and then also reuse opportunities, which we've touched on as well, for demo and refurb builds. Another thing to point out, I think it's useful to understand it when relating to planning consultants here as well. You know, a lot of planning consultants kind of drive the pre-REBA stage 2 need for whole life carbon, and this is why, essentially, because there's a greater influence. So yeah, the next couple of slides, just going to take you through one of our many projects we work on with our major client, Savills. This is the Bourne Quarter development. This is located in Cambridge. It's a 3-phase development covering 25 acres. It was addressing the local borough's need for industry with a focus kind of on the life sciences. And we're just going to click through this video here. So what you can see is this is the phase 2. So it was a 9-unit industrial development. We were involved very early on around the preparation brief stage, stage 1. What that enabled was a great influence on whole life, the operational energy strategy, And I'm going to hand back over to Manus here. He's going to take you through some of the results from our work there.
Thanks, Adam. As Adam and myself were involved on the BREEAM and net zero side of this project, due to the early design stage intervention, we were able to find the baseline carbon performance of these units and then focus on those carbon hotspots. Following this, we undertook a design team workshop where we opted for sustainable alternatives and construction practices to have those carbon emission savings. Undertaking this particular exercise helped us focus those focusing on those carbon hotspots and maximizing those big savings. Savills were able to reduce the upfront carbon emissions by 657 tons. And the client over here wanted a net zero upfront carbon development, which basically means they wanted to offset all their upfront carbon emissions. And undertaking this whole life carbon study at the early design stage helped them save around 164,000 pounds in offsetting costs. Also, at the early design stage energy modeling, all the industrial units were able to achieve operationally net zero and A+ EPC rating, which was by reducing the energy demand within the building and utilizing the rooftop PV systems. Also, an important thing to note that the project also aims to integrate locally manufactured PV panels, because this reduces the embodied carbon emissions coming from the transportation or importing the foreign manufactured ones. In conclusion, the whole study focuses on embodying a sustainable approach and the financial incentives that come with by undertaking a whole life carbon assessment at the early design stage.
Cheers, Vance. So go back 10 years, probably whole life carbon was lesser known. I think what this slide does here is kind of demystifies its growth, I guess, and prominence in the built environment. Built environment accounts for approximately 40% global greenhouse gas emissions and raw material extraction. So we start off in 2015, the Paris Agreement, first kind of major international agreement with over 180 nations to try and limit global warming reduction to 1.5 degrees Celsius. And yeah, so that clearly prioritized decarbonisation of these major contributing sectors, being the built environment. Moving on from that, we had COP26, that was in 2021, more recently, and there an agreement to try and limit 68% carbon dioxide reduction by 2030. So moving kind of internationally to UK-based legislation as well, we had the Act of Parliament in 21. And this was an interim target. This was a 78% reduction by 2035, with its intention to kind of show that we're on track, making progress towards the final and I suppose pinnacle, which is the legislative 2019 Act of Parliament agreement to achieve net zero by 2050 in UK. And that's essentially what we're working towards. That's a major goal. So on screen here, we've got we're showing the local boroughs where whole life carbon is a mandatory service. So where it is required for kind of all major developments. What we haven't included here are the boroughs where it's a recommendation or it's a policy extension. I guess what we're increasingly seeing is that minor and adjacent boroughs to these major kind of the main urbanized areas of the UK, we're seeing that they're looking towards the kind of big brother, if you like, the big brother boroughs to set the policy, set the goals, and they're striving towards also including those targets within their own policies, or even referring to the London Plan kind of as the kind of main leader, kind of paving the way, if you like, across UK policy. If we were looking at this graph in 3 to 5 years' time, I think we'd expect to see many, many more boroughs on the screen. And I think the ones where they're currently a policy would even be looking towards benchmark sets for whole life carbon targets. So yeah, out of the policies that we touched on, to kind of driving towards our net zero target, there's been international and national standards which are trying to pave the way here. So we've got ISO on screen there, which is international standard for quality of service and products. British standard, which is UK regulatory body for the built environment. And I suppose most notably the recommended guide reports that have come out of this have been ISO 15978 and 15804, which paved the way for how to quantify products life cycle, and then also how to kind of separate the life cycle stages throughout a product's life as well. From these standards, then grew kind of RICS. The first guide on whole life carbon was in 2017, and then more recently, one which we worked to and local boroughs in this year. We're expecting it to come out at the final version later this year, and that really sets the principles of how we go about calculating a development's whole life carbon, relating right down to transport distances, transport fuel types, life expectancy of buildings. I guess we call it the Bible of whole life carbon in a way. So these are based on regulations, the standards, but kind of beyond that, to improve where we are currently, we need these non-governmental research organizations to set higher expectations, kind of targets for whole life carbon that we strive towards. So these groups include LETI, which we referred to earlier in the presentation, UK Green Building Council, ISRE, and CPD as well. And yeah, these are really the drivers in the industry that are pioneering the way to better performing buildings in a whole life carbon context.
Thanks, Adam. So as Adam explained before, and building upon the national and local regulations, to enable further carbon reduction in the built environment, there is an industry-wide push for a new building regulation document called Part Z. This legislation mandates whole life carbon assessment for all the commercial developments above 1,000 meters square and all the residential dwellings greater than 10 dwellings. And following consultations and various amendments, the legislation is set to be released by January 2026. And upon its release down the line, when the government has collected sufficient database, they will set to implement upfront carbon limits, which will be followed by all the buildings following that. Most of you might know that BREEAM certifications are a planning requirement in most of the local authorities across the UK, and BREEAM methodology is undergoing a massive update later this year. They are integrating such consistent carbon measurements and integrating whole life carbon assessments, which will be notably reflected in the materials criteria of BREEAM. This harmonization of LCAs in the BREEAM methodology helps them track the net zero approach or a net zero pathway of a building, which will enable all the assessors to measure and benchmark their embodied carbon. So what are the few key takeaways what we want you to take from this CPD?
So it's probably become clear throughout this CPD that engaging in reducing whole life carbon absolutely has to happen in the early design stage. Leaving it any later is not only going to lead to greater costs, but to more restricted options for reducing whole life carbon. The policy and regulation is only going one way, and it's becoming more widespread and more stringent. Climate change and the resulting regulation isn't going to go away, but it's not all red tape and regulation. There is good news. Focusing on reducing whole life carbon will reduce operational costs. It will protect an asset or a development against the increasingly stringent regulatory environment. But also, if marketed, it has been shown to increase rentable values and asset values. Hazel, thank you. I think you've been taking questions, but if anyone has any questions, please do ask. We've got some time left at the end, so fire away either in the chat or unmute yourselves and ask.
Hi, yeah, it's Jacob here speaking. Thanks for the presentation. Just got a quick question. So when we've got a whole life cycle assessment, what's the percentage like, in terms of operational cost does it reduce it by? Because I think you did mention that it does reduce the operational cost of the building, but like, I'm just keen to know what's the sort of percentage we're looking at.
Manners, do you want to answer that?
Yeah. I'll answer that. So in terms of operational costs, when we undertake it at early design stage, we model it as an ideal building, and we reduce the energy demand inside the building by tweaking the fabric, the MEP systems or the occupancy profiles. Main goal is reducing the energy demand and then maximizing it through implementing PV. And use of PV has shown that it offsets your operational carbon by some sense, and that's where you see the savings in it. It's a very gray area to give you a number, but it differs from case to case. It depends on how much PVs can be implemented.
Yeah.
I mean, another case that we did actually for Savills as well was Cathedral Hill near Guildford. And again, that got to operational net zero. So, you know, negligible costs. And again, that was using PV and Tesla batteries.
Yeah. Okay. Thank you.
Thanks, Jacob. Any more questions?
There might be one in the chat.
Hello, and thank you for the presentation, very helpful. I was just wondering, you mentioned briefly about there being a source of UK constructed PV. Is that something that you have been able to specify, and sort of how big a percentage of market share do they have, and is it growing?
That's a good question.
On the yeah, no, I can touch on that one for you. So yeah, that was part of the operational energy and whole life, I suppose, investigation we did for Bourne Quarter. So we took a case of a Cambridge panel that was actually manufactured less than 10 kilometers down the road, and then we kind of paired that up against a standard product in the market, which was constructed in China, and then kind of incorporated what kind of transport costs, the carbon associated with that transport as well, how that would come into it. The Chinese panel was a more efficient panel than I think it was around 3-4% more efficient. But overall, in terms of carbon, we're able to show that kind of based on the upfront emissions associated with it, the Cambridge panel would be more beneficial, and it could still achieve operational net zero, which is the client's proposal.
And also building on that, I think in most of the case studies that we are doing, or most of the projects that we do, we tend to recommend UK manufactured or at least EU manufactured panels, because the foreign manufactured panels are quite cheaper, but when you factor in the embodied carbon and the transportation emissions, there's a massive trade-off. So there's a massive we lean towards UK manufactured or EU manufactured panels just to have those lesser embodied emissions.
So just a second off the back of that, in terms of efficiency as well, Paul, even though I suppose the nominal efficiency would be higher, there's so many more factors which come into it, which would potentially affect operational, maintenance, the actual angle of line, angle of incidence from the sun. So yeah, we considered all that within the calculation as well.
Thank you. I'm delighted to hear someone in the UK is making them.
Yeah, there used to be, in about 15 years ago, there used to be a company, Philsol, in Wales, but that's no longer, sadly. But yeah, they're doing it in Cambridge now, which is great.
Thank you. Hi, everyone. Can you hear me?
At least you got a good breath.
Hi, is this Danny or Richard speaking?
This is Richard speaking. Hi.
Hi, Richard.
I'll switch out. Hi, everyone. Thank you very, very much for putting on this series, and especially starting off with whole life carbon. I have a question about accessing carbon databases and how you're estimating the carbon dioxide equivalent of materials and systems. So I'm aware there's a number of databases across the world.
Yeah.
And I suppose it changes depending on the stage of the project. So, are you using the ICE database to start, and EPDs environmental performance declarations as the project moves on. And in addition to that, what's your take on the built environment carbon database, if it's yet functional? Do you
That's
use
a
it
really
at
good
all?
question, and it's something that's changing
Thank you.
all the time, and we're learning, and everyone's learning, and that's where, again, collaboration is really important. But I think Manus can tell us about the software that we use and where we get our figures.
So we use one-click modeling software tool, which has all the database of the EPDs, it's generic database as well, and it has all the authentic IC database as well. They update it on an annual basis as well. So it's not like a big black box. It's an open source software tool which we use it for a whole life carbon modeling. And regarding touching base on the BECD point, we are generally using that database for just benchmarking like a baseline, and then we use those figures from BECDs just to as an improvement over what is the industry average at the moment.
Does that make sense?
Interesting. Yeah, absolutely. That's really great.
So we use one click, but we benchmark.
Oh, that's brilliant. Thank you. Thank you.
Thanks, Richard.
Danny, did you have a question as well?
Hello?
Hi.
Hello? Hi, can you hear me? It's Daniel.
Yes.
Yeah.
Hi. We're just about to consult you on a project in Lewis, which is in the South Downs National Park. And we've just had a recent design review panel meeting, which has gone quite well. But we're being asked to incorporate a high level of PVs, air source heat pumps into the scheme. And we've got a competing interest here between what the planners may want and what the heritage people are looking for. So how do we go about that as a sort of preliminary issue, taking into account the need for the aesthetics of not having necessarily ugly panels on the roofs and that sort of thing? So this is the dichotomy for us.
Yeah, that's a good question. Adam, do you want to answer that?
Yeah, I can start with that if you want, Danny. Yeah, I think in the first instance, we think about whole life carbon as a group, embodied and operationally. Manus touched on earlier about the energy hierarchy. So we'd look to reduce the actual demand first of all, which from that we'd hope that actually there'd be less operational needs. So in the first instance, there wouldn't be as much PV that would be required to meet that operational demand, which I think would certainly kind of suit and benefit the case you're talking about.
Okay, well that's interesting because we'll be jumping on this very soon, and I'll be interested to see how things develop. So thank you, and also thank you for this seminar. Very useful.
Thanks, Danny.
Thanks, Danny.
I think we have a few questions in the chat.
We do, yeah. So Annie Ruth has asked, can I ask what alternatives are there for reducing upfront carbon from substructures and facade?
Manus.
Yeah, I'll answer that. Substructure, basic approach would be opting for building less or retrofitting. But if it's a complete new build on a greenfield site, we generally opt for low embodied carbon materials, and especially for substructure, if the general use of concrete elements, we tend to consult with main contractor as well to integrate higher recycled content, and also opt for locally manufactured concrete, which is usually within 50 kilometers of the site. So that directly affects your upfront carbon emissions for substructure. And facades, I think we had a meeting with Kingspan as well, because we are seeing insulated cladding panels being used a lot in most of our projects, and due to this push of reducing upfront carbon, the manufacturers are also producing these LEC or lower embodied carbon panels, which the main contractor or the design team can opt for reducing that upfront carbon.
Hopefully whole life carbon will be a good thing for British industry. We can hope.
Okay, next question. Nadira has asked, Can you please clarify the difference between using RICS methodology and the scope methodology?
So if you didn't hear that, we've been asked to clarify the difference between the RICS methodology and the scopes methodology. Adam, do you want? Or Manus?
What scope are they referring to?
You're not sure
I'm not
about,
sure
yeah.
what the scope methodology is. Could you clarify that? But should we go to the next question and maybe that question could be clarified? Thank you.
Sure.
Sorry, we can't answer it straight away.
Simon Harrington has asked, when WLCA became mandatory, will this be via BREEAM, and will the BREEAM rating affect what needs to be achieved?
Yeah, so that's the question around BREEAM and WLCAs becoming mandatory, which we did touch on, but I know that's Adam's field, so he can expand on that.
For Simon, was it? Yeah. Yeah, we're very excited about V7 coming out probably May, June time potentially. We've kind of been involved in a few consultations at this stage. Obviously, a lower benchmark will achieve greater credits. We've heard that there will still be an advantage to stage 2 involvement. There'll be more credits available for being involved at that stage. And I think it's a move that's been needed in BREEAM for quite a while, to be honest. As whole life carbon's been progressing, I feel like BRE have been a bit stuck in the mud in that essence. So yeah, it couldn't come soon enough.
Does that answer your question?
Yeah, hi, sorry. Yeah, no, thanks. It does. Yeah, it does, correct.
Thanks, Simon. We've got another question here. I haven't got my glasses, so Manus is going to read it, that bottom one.
it's from Mike Cleveland. What can we expect house builders to have provide for building regulations, Part Z submissions, and demonstrate compliance? So, yep. I think that's a question. I'll answer that question. So when Part Z is implemented, it will usually follow the RICS guidance methodology. So you are usually asked to prepare a report and fill out this big spreadsheet, which is very complicated, I would say. But we are there to help you out. So that's what a whole life carbon assessment comes with. You fill out a spreadsheet which consists of the carbon emissions across all the life cycle stages of the building. So that documentation will be part of the planning requirements or the planning document submission.
We've been asked if there is a low carbon structural steel supplier in the UK. I know that they're doing quite a lot on recycled steel, and more of this coming out on that. And there are quite a few initiatives to do that. But in terms of recycled steel, any manufacturers? I
think Celsa Steel is one of the manufacturers who do use renewable energy to manufacture steel, and they also incorporate higher recycled content in their structures. So they are one of our recommendations when we opt for those sustainable alternatives in the structure. So yeah, Celsa Steel is one of the manufacturers.
Like key words, key things to look out for there. CARES is a good responsible sourcing materials metric. That can be a kind of certification that comes with the manufacturer of steel. Quite often they come with recycled content and lower carbon in their production. So yeah, look out for those.
There was one around the Part Z. Can we expect house builders to provide for future building regs Part Z submissions and demonstrate compliance? Adam?
Yeah, I think I touched base on that.
Okay,
so
thanks,
yeah.
I think that's all the questions we've got for the minute. Does anyone else have any that they want to unmic and ask? Thanks, Mike. Thanks for joining us.
Hello, sorry, one question. I was just Googling, is it Sensa steel? S-E-N-S-A, Sensa steel.
It's Celsa, it's C-E-L-S-A, Celsa Steel.
Sensa. Perfect.
Yeah.
Thank you so much.
For joining us. Good to see you.
And you as well, thank you. Bye.
I think there's one more question over here.
Are we able to calculate the estimated embodied carbon within an existing building to quantify its value versus demolition and replacement?
So I think this comes as a part of the retrofit approach.
Yeah.
As per the RICS guidance, they suggest that if you are undertaking whole life carbon for an existing building, the embodied carbon of the existing materials is assumed to be zero, because you can't retrospectively go back and to carry out the assessment. But whatever new elements is added, is it your insulation, is it your partitions, is it your MEP system, all the new elements will have the carbon emissions, but the existing materials is assumed to be zero. That's why the government is focusing on a retrofit first approach. And I think that will become mandatory for if you're working on an existing building and have a plan for demolishing the existing building. You need to justify why you're why demolition is the more sustainable approach.
Yeah. Where there is an existing building on the site, auctioneering of whole life carbon options is something that we're doing progressively more. There's a City of London emerging policy, which will likely be taken into kind of the whole Greater London Authority within the next couple of years, and that is to address how does the demolition and rebuild compare against light retrofit, deep retrofit options, and yeah, we love getting stuck into options like that.
And on the retrofitting, again, the UK Green Building Council has just published a paper last month on retrofitting of offices. So that's a good read, 70 pages, but a good read. Does anyone else have any other questions?
Hi, my name's Max. I do have a question on sort of renewable ground source heat pumps. So everyone's air source is very popular. Ground source is quite challenging when you need a lot of area to deal with it. How popular in the UK are borehole solutions? I do schemes in Scandinavia where the borehole solution is very, very popular and commercially quite inexpensive. In the UK, how popular is it? Is it expensive? Do you get the benefits?
So that, yeah, I think most of the schemes that we have come across don't usually offer ground source or borewell heat pumps, because the more effective approach is coming from an air source heat pump point of view. But I think I'll get back to you more effectively when consulting on the energy team, because they are effectively doing the energy modeling side of things, and expand more on that. I'll note down that question for you.
Yeah, because I just know we're doing a big commercial scheme, and where we had Rambol as an engineer, and interestingly, one of the engineers had his own borehole put in his garden, and he says he operates his whole house using that throughout the year. So it sort of makes you feel that there obviously is an industry out there to do it, and if you can benefit from being, you don't have any energy bills to pay. I just don't know how forward thinking the UK are in that respect as to say the Nordics.
Yeah,
it's not something we've come across a lot. As you probably know, SRE has been going for 18 years, and
yeah.
So before air source heat pumps were readily available on the market, but ground source heat pumps were about 10 years ago, and actually there wasn't a huge amount of take up amongst our projects, partly because of the coefficient with getting the heat out of the ground with the energy that was required.
Yeah.
And also there were a number of projects where they had problems, maintenance problems. So, but the uptake of air source heat pumps seems to be much more widespread.
The reason I ask is, if you're doing a residential scheme of 500 units, what you don't want is 500 units bolted onto a building. They look ugly, or you have to design them in. Whereas when you go through a scheme where it's a sensitive site, if you can hide it in the ground, it's a much better solution. But it probably comes with a hell of a lot more cost, or
I think
less efficient.
Adam,
I just didn't know whether the industry is sort of trying to push that side of things further.
No, yeah, I'd agree, Max. I think site constraints actually, can come into it quite significantly. I think that's why air source is preferred in a lot of instances with the smaller sites, especially London-based. Yeah, you obviously got kind of domestic incentive air source, which kind of shows the government direction where they want to go with that with grants. I think generally we do tend to see better efficiency from air source from the energy team that work on it. And there's improvements in carbon there to relate back to carbon there. refrigerants being used there, they're changing. There's potential to use CO2, water, ammonia, and yeah, that's just bringing down the total carbon of those systems as well.
Okay, lovely. Well, thank you for that.
Thanks, Max.
Any more questions?
No, thank you.
Thanks, Max. Do we expect to see offsetting requirements, contributions where whole life carbon? Those could be doing offsetting.
So at the moment, there is no offsetting cost required in the GLA if you exceed those limits, but you have to provide a justification for why you're exceeding those limits established by the GLA. But down the line, I think when the part Z is implemented and they have enough database to establish those appropriate limits as part of the building regulation, as a building control sign off, then we might be able to see an offsetting cost attached to the excessive carbon or the exceedance of a limit. But at the moment, there is no penalties associated with it, penalty or a fee associated with exceeding those limits.
Thank you. I think we've done all the questions in the chat. If there's any more that people want to unmute themselves.
Yeah.
One's just come
Hi.
in.
This is
Hi.
Nadira. This
Hi.
is Nadira. I just added a question in the chat, and it's about your case study for Bourne Quarter.
Yeah.
What was the main elements that influenced the calculations for your carbon assessment at early stages? Would be interesting to see that, perhaps.
So there were three major key considerations that we were able to change in the design, because as the phase 1 was already done and the phase 2 was on the way for planning, we didn't have much room to architecturally change the design. So we opted for changing the substructure, where we increase the recycled content from 0% in the baseline model to up to 40% by consulting with the structural engineers, because that is the maximum recycled content that you can have in a substructure. And similarly, for the steel elements, the phase one of this project didn't have any recycled content. It was all fully virgin materials, and from there we increased the recycled content in the structural steel as well, planning to resource them locally as well, and increase that recycled content up to 35%. So the recycled content balance was done by partnering with the structural team as well. That's for the structure. And for the PV, as we told, we modeled the baseline for the phase 1. The PV panels were shipped from China. They were like, I don't have the model as JA manufactured, but for this phase 2, we are hoping to get those panels locally manufactured from the Cambridge sites, which reduces the A4 emissions, the transport emissions. So having so we're focusing on the big hotspots for the PV and substructure and structural elements, and reducing there, where we are able to have around, I think, 5 to 10% of carbon savings site-wide.
Does that answer your question, Nadira?
Yes, definitely. I mean, it gives, but I guess the MEP as well would be something, but I'm not sure. Obviously, you're
MEP at the early design stage, it's yes, Nadira. I think at the early design stage for MEP, we can only recommend to have refrigerant-proof piping, because when you consider the carbon percentage of MEP versus the substructure and structure of the building, is quite slow, quite less. So we focused on the structural part of this project, and later on, where we are involved in the technical design stage as well, where we have more information on the MEP, we can thereon consult more on that part.
Okay. Thank you. That's useful.
Thank you, Alice. In terms of cost, how much of a premium is there with integrating low carbon materials at the moment? Do you see them decreasing in the future? I would say, in terms of the materials and the low carbon materials that are coming on the market, I think again, they're only going to go one way, which is reducing in cost, which is what we've seen with all the other technologies. For example, PV panels, ground source heat pumps that went for them. And if you've got anything else to add, do you think things will reduce in price?
I do, yeah. I don't think they are as much of an innovation anymore. There's certainly a growing demand, and with that, obviously, more and more being produced. And yeah, I agree with that direction for sure.
We were at Footprint, the kind of for the sustainable built environment exhibition that was in Brighton last year and is going to be in London at the beginning of this May, and there was a lot there about low carbon materials. So that would be an interesting place to look.
And just to add on that, I think it's low carbon materials is just the scale of economy. As more and more people opt for it, the cost is gonna keep driving down as well.
Does anyone else have any questions? We're coming to the end of our timing. Please unmute yourself if you'd like to ask, or pop them in the chat. Great. I think we're going to bring this to a close. We're obviously available if anyone's got any further questions, or if we can help you on any of your projects. And we've got 3 more CPDs that we're doing covering a similar thing. The next is on Thursday, the 28th of March, and it is designing to net zero. So it's incorporating a lot of what we've talked about today, but looking much more on how we can design whole life carbon out in the designs of our buildings. Thank you for joining us, and see you then.
Thank you.
Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye-bye.
Thank you very much, guys. Bye.
Lovely to see you.
And you as well. Bye.
Bye.